Welcome to Penrose Learning, where we make understanding easy.
You begin by gathering the core parts and making the first electrical connections. Mount the motor to the wheelbase and attach the encoder directly to the motor shaft. This ensures accurate position feedback. Wire the motor driver to the motor and connect the driver's logic input to Arduino pins while using a common ground. This prevents floating references. Once powered by the 1224V supply, flash a simple encoder read sketch to confirm counts and direction, because early confirmation saves debugging time later. Now you implement the core control loop and load the firmware that turns encoder data into force output. Read encoder counts at a stable 1K Hz interval, compute velocity and position error, and run a PID to produce torque commands. This is how you translate steering input into controlled feedback. Apply a low-pass filter to velocity to avoid jitter, and add current-limiting logic to the driver to prevent stalls. Make sure to test with low gains, because aggressive tuning can damage hardware or make the wheel violent. Finish by calibrating and integrating the wheel into your simulator. Center the encoder and map counts to steering angle, then ramp torque commands slowly to build a PWM to torque table. This ensures predictable forces. Connect Arduino to the PC as a HID or bridge via serial and test game force calls while smoothing inputs on the Arduino side. If you see jitter, overheating, or noise, reduce PID gains, add a small deadband. Verify solid ground connections, and monitor motor current. These steps fix most problems quickly.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.